Hello once again. We are now down to the last lesson about compound interest. And after finding for the compound amount and finding for the present value, we will now proceed to finding the nominal rate for the compound interest. So as just with the present value system, we derive the formula from the F. We will also do the same with the formula for the nominal rate. So this is now the process of the derivation of the formula from F is equal to P times the quantity of 1 plus I raised to the power of N. From the formula of the future value, we will now try to make this I, the variable, be the one that will be left out so that we will know the value of I. But that is just the interest rate. Our goal is to find for the value of the nominal rate. So as you can see the process, we have F is equal to P times the quantity of 1 plus I raised to the power of N becomes F over P by dividing both sides by P, that's the principal, to eliminate P on this side. That's why we have the quantity of 1 plus I raised to the power of N as the remaining term in our right-hand side of the equation. Because we have an exponent N in this quantity, wherein I belongs to, and we need to take out I. That is why we need to eliminate as well the exponent on this side. Eliminating this means we have to raise both sides to the power of 1 over n, because 1 over n times n is equal to 1. So after raising both sides with an exponent of 1 over n, this will become f over p raised to the power of 1 over n, and the other side will have 1 plus I, since the n was already eliminated. So now it's easy for us to eliminate 1 and to let I be the only term in one side of the equation. So applying the commutative property of equality, we have I is equal to, we can just transpose, that's the term that we may also use, transpose 1 to the other side, or you can also apply addition property of equality by adding negative 1 to both sides. Either way, you will get F, or the quantity of F over P, that's F over P raised to the power of 1 over N minus 1. So I hope I'm not caught by this presentation because we are having internet connection problem. So I will just continue. Okay, so we don't have any problem about this. We are still on. So the value of I, therefore, is equal to the quantity of F over P raised to the power of 1 over N minus 1. But we are looking for the nominal rate, and this is the interest rate. And usually the problem is asking for the nominal rate. That is the rate that is being stated in the problem before you converted it into interest rate, considering the conversion of the amount, because we are talking about compound interest. So that is convertible to J over M. Since we all know that I is equal to J over M, then we can also transform this into J over M, this one, is equal to the quantity of F over P raised to the power of 1 over N minus 1. Since J is the unknown, so we can just apply multiplication property of equality, multiplying both sides by M. That is why we have J is equal to M times the quantity of F over P raised to the power of 1 over N minus 1. So that will be our formula. This is our guide right now in solving the rest of the examples in finding for the nominal rate in a compound interest problem. So take note of that formula. First example, at what rate compounded quarterly will 7,000 pesos become 1,800 pesos at the end of 11 years? So from the problem, we will get the important facts to be included in our solution. 7,000 pesos will become 8,500 pesos. Therefore, 7,000 pesos is our principal, our present value, and 18,500 will be our future value. At the end of 11 years, so 11 years is our T or term, and there is no need for us to use fraction in this particular example because the given time is in years. M is quarterly, so it is equal to 4. And I also included N Mentally, you can solve for n by multiplying t and m. That's 11 times 4. So that's 44. So that's automatic. Applying that particular formula, you just recall J is equal to M times the quantity of F over P raised to the power of 1 over N minus 1. We will obtain these values. 4 for our M, F 18,500 rather, P is 7,000 raised to the power of 1 over 44, which is our N minus 1. Solving this using our calculator, scientific calculator, is very useful. But you can also use, I don't know if fractions and the exponents are still available in the ordinary calculator, but as math majors, it's good to invest in scientific calculators. So you can just press this at once following the correct syntax, and you will get a decimal of 0.089333922. So if that is the case, we can just move two places to the right this time because we are converting decimal to percent. So if the instruction is telling us convert into percent with two decimal places, therefore we will just have 8.93% as our answer. That is the final answer. That is the nominal rate of that particular problem. Second example, for a sum of money to double itself in 8 years, what must be the nominal rate converted monthly? So double the money. So this has been a problem that was already exposed to you the moment we started with interest, simple interest. So we will use a generalized form because there is no specification of as to the amount of money that will be doubled. So if we are going to generalize, we will use letter. So if our principal is x and if we are going to double that, so that's 2x, twice that value, that will be our f. So if x is our investment and it will become 2x, then we have just doubled our money. So that is the representation for the P and our F as well. And 8 years will be our T. The nominal rate is being asked, converted monthly. Monthly is 12, so M is equal to 12. N is equal to T times M, so 8 times 12 is 96. So we have all these things that we will be utilizing in our solution. Still, our formula is Y is equal to M times the quantity of F over P raised to the power of 1 over N minus 1. M is equal to 12. So please check properly. 12, and then we have the quantity of 2x over x raised to the power of 1 over 96. So solving this, we have to eliminate x because x divided by x is equal to 1. So we are just left with 12 raised to the power of 1 over 96. Then minus 1, then this value will be multiplied by 12. So kindly check if the answer is really correct, since we have already a clerical error a while ago for the value of m, which is supposedly 12 from 4. So you must get the correct answer after doing that. Okay, so let's proceed to number 3. Nora borrowed 10,000 pesos from Vanessa and agreed to pay 700 pesos per month for 6 months. So there is now a clue about the payment. So the principal is given 10,000 pesos, and what will be the future value? It's not stated here, but there is a clue. The payment is 700 pesos per month for 6 months. Again, the question is the nominal rate. What is the nominal rate? At what nominal rate compounded monthly is she paying the interest? So from the problem, 10,000 pesos is our principal. The payment of 700 per month, that is 700 times 6, will give us 4,200 as the amount of interest. Adding the amount of interest I and our principal will give us F, that is 14,200. This is a fundamental formula from the first lesson, that the future value is just equal to the present value plus the interest, regardless of the type of interest, whether it is a simple interest or a compound interest. The concept is still the same. So it means that our future value is 14,200. So we are safe with that. What are the other things that we need to uh, get from the problem? We have 6 months as our term. That is 6 over 12 because our term should always be expressed in terms of years. So that's 6 divided by 12, or 1 half. or zero point 0.5. M is monthly, that is 12. And from this, we have 6 over 12, or 1 half times 12. 1 half of 12 is 6. That's why n is equal to 6, because n is equal to t times m. Substituting those important values in our formula, we have m is equal to 12. That's why we have 12 times the quantity of 14,200, our f, 10,000 our p, raised to the power of 1 over our n, which is 6, then minus 1. Calculating this, you should get this value, 72.22%. That is how to compute for the nominal rate in a particular compound interest problem. So I think that's it. So that is the pattern in solving for the nominal rate in a compound interest problem. So overall, if you are going to recall all our lessons from the compound interest, from finding the compound amount, finding the present value, and finding the nominal rate, we can just stick with one formula. That's the fundamental formula in finding for the value of f. And from that, we can derive the other formulas. So that is just very simple. So all we have to do is to familiarize the formula and always bear in mind all those concepts about the nominal rate, about the value of m, about the value of n, and so on and so forth. Your exercises will still be posted in your Quipper. So if you have further questions, again, you may just send me a private message. So I hope this video will help you in understanding the lesson, because this is part of our second examination. This ends our discussion, and please prepare for our examination. That would be all. Thank you so much for your time. Mabuhay kayong lahat.